All right, moving on to number 6. We've got aluminum plus copper 2 chloride yields copper and aluminum chloride. All right, so this is our first single replacement reaction. These are a little bit different. The first thing you need to note is that aluminum does not dissolve in water. You know that. If you took a piece of aluminum foil and crumpled it up and put it in water, it would just float on top. It would not dissolve. So we're just going to bring aluminum down and leave it by itself. All right, moving on to copper chloride. Looking at our rules, it says all chlorides are soluble. Copper is not on the list of exceptions, so that means it will split. And remember, this copper has a +2 charge. Now, notice when I brought aluminum down, I did not put a charge next to it. It did not split from an ionic compound, so I'm not putting a charge next to it. That's important. All right, on the right side, copper is also a metal. You know that copper does not dissolve in water. It's just a metal. We're going to bring it down. We're not putting a charge next to it because it did not split from an ionic compound. And then lastly, we've got aluminum chloride. Using that same rule about chlorides, all chlorides are soluble. Aluminum is not one of the exceptions. So that is also going to split. All right, so now we're going to cancel out our spectator ions. Keep in mind that we cannot cancel out aluminum. Aluminum here is a metal. We can see it. Aluminum on the right side is an ion. We can't see it because it's dissolved in water. So those are two different things. They will not cancel out. Same thing with copper. On the left side of the equation, copper is invisible. It is dissolved in water. On the right side, it is a solid metal. You can see it. So those are two different things. So the only thing we're going to cancel out are your chloride ions. Both of those will cancel. They don't take part in the reaction. So writing out our net ionic reaction, the only thing we have left to do is to balance it. Now our atoms are balanced, the charges are not. On the left side you have a +2 charge, on the right side you have a +3 charge. We want them to be balanced. The first number that 2 and 3 will go into is 6. So I'm going to put a 3 in front of my copper and a 2 in front of aluminum. +6, +6. Now that you've done that, you also have to balance the atoms. So 3 coppers, 2 aluminums, 2 aluminums. So now the equation is balanced. And if you look back up at the original equation, it ends up being the same coefficients we used to begin with. All right, moving on to number 7. For number 7, we have iron. This is one that we did not do together. You did this one on your own. And they told you in the notes that iron 2 will be used in the product. So that means there are 2 acetates bonded with iron, and silver is by itself. And then to balance it, you had 2s in front of both of your silvers. All right, this is another single replacement reaction. Just like we did with number 6, we're going to just move iron down. Iron is not splitting from a compound. It does not dissolve in water, so we're just going to bring it down. For silver acetate, you have a rule about acetates. Same as nitrates, acetates are always soluble. So that one is going to split. Same thing on the right side. This is an acetate. All acetates will split. So we'll write those as ions. And then lastly, silver is just a metal. We're going to bring it down. So the only thing that will cancel out is your acetate. That appears on both sides. So your net ionic equation is iron plus silver ion yields iron ion plus silver. And we will have to balance this. Since iron has a +2 charge, silver has a +1 charge, I'm going to put a 2 in front. So now it's +2 +2. And since I have 2 silvers, I'm going to put a 2 in front of the silver on the right side. So now this equation is balanced. All right, looking back at our worksheet, I'm going to skip number 8. That's a combustion reaction that doesn't apply here. And I'm going to move on to number 9. All right, number 9, we've got ammonium sulfide. This is another one that you did on your own, and iron 2 nitrate. So this is a double replacement reaction. On the right side, iron is with sulfide, ammonium is with nitrate, with a 2 in front. Looking at our rules, looking at our rule about sulfides, that's rule number 7. All carbonates, sulfides, sulfites, phosphates, and oxalates are insoluble, except for those with group 1 and ammonium. So there's your exception. Ammonium sulfide is soluble, so that will split. All right, we see nitrate. All nitrates are soluble, so that's going to split. On this side, we see sulfide again. So we're going to look at Rule 7. Remember it said that all sulfides are insoluble except for group 1 metals and ammonium. Iron is not either of those, so it is going to be insoluble. It will stay together. And then lastly, all nitrates are soluble, so that will split as well. So we're going to cancel out our spectator ions. That's going to be ammonium and nitrate. And your net ionic equation is sulfur ion, sulfide ion, iron 2 ion yields iron 2 sulfide. And it's already balanced. All right, moving on to number 10. Number 10, you had sulfuric acid and potassium yields potassium sulfate and hydrogen gas. And I hope when you did this one on your own, you remembered that hydrogen is a diatomic molecule, so it has to exist as a pair. All right, so once again, we have an acid. Your rule about acids says that if a substance is an acid, only these are soluble. Sulfuric acid is one of those. So that's going to split into hydrogen ion and sulfate ion. Potassium is a metal, so we know that it's just going to come down here, no charge. It didn't split from an ionic compound. Potassium sulfate. Potassium is a group 1 metal, so all group 1 metal compounds are soluble. That's going to split. And then hydrogen gas is, we're just going to bring that down as H2. That is not going to split. It's a gas. Remember that if something is insoluble, it's either going to be a precipitate or a gas. So here's our first example of a gas. So the only thing that will cancel out is sulfate. So we've got hydrogen ion plus potassium metal yields potassium ion and hydrogen gas. We have 2 hydrogens on the right, so I need to put a 2 here. Putting that 2 here gives me a +2 charge, so I need to put a 2 in front of my +1 charge on the right side. So it's +2 +2, and now I have 2 potassiums, so I need to balance my potassium atoms. So my charges are now balanced, my atoms are now balanced, and I am done. All right, now we're moving on to the back of your worksheet. We're on number 11. Aluminum sulfate plus calcium phosphate yields calcium sulfate and aluminum phosphate. All right, so let's see if aluminum sulfate is going to split. Your rule about sulfates says that all sulfates are soluble, except aluminum is not one of the exceptions, so that is going to split. All right, calcium phosphate. Your rule about phosphates is that all phosphates are insoluble, and we don't have an exception here. Calcium is not on that list. So that's going to stay together. On the right side, you've got calcium sulfate. All sulfates are soluble except calcium is one of the exceptions. So calcium sulfate is going to stay together. And then lastly, we have aluminum phosphate. Phosphates, all phosphates are insoluble. Aluminum is not an exception, so that's going to stay together. So for this, the only thing that split was our original compound here, and we're not going to cancel anything out, so we just need to balance the equation. So we have 3 calciums, put a 3 here, 2 phosphates, put a 2 there. That gives me 2 aluminums. I'll put a 2 in front of aluminum, and I have 3 sulfates, so I need to put a 3 in front of sulfate, and now my charges are balanced, +6, -6.